Okay, so let's explain the three lines here. So first off, they start off by giving you this recurrence formula, but they actually gave it to you in terms of n. Un equals to un minus 1 plus 2 power n plus n minus 1. The trick here is you need to understand that this is a recurrence formula where you have a rth term expressed in terms of the r minus 1 term. The trick here the nth term expressed in terms of the n minus 1th term given by the question. But the trick here is to replace the n with a r first, with a r, and then after that they also gave you the hint you want to look at un minus 1, or in this case it should actually be ur minus 1, and then after that you take the summation from r equals to 1 to n. This is just a trick. Then why do you want to do that? It's because you will eventually be able to get an expression for un purely in terms of n. No more u's. Let's see how we can do that. So by taking the summation here, you're really just doing a method of difference. The key trick is that there's a minus here, the ur minus 1. Then after that, if you open up this summation by manually substituting r equals to 1, r equals to 2, r equals to 3, all the way to r equals n minus 1, n minus 2, n minus 2, n minus 1, and lastly n, one by one, you'll get this expression. Just sub it into the r one by one. What you will realize is that u1 minus u1, u2 minus u2, u3 minus u3, so on and so forth, until you're left with the top half and the bottom half. Or actually not half, just a single term at the top and a single term at the bottom. Then it simplifies down to un minus u0. What's so good about that? What's so good about that is that u0 has already been given to us as 1. So this is equal to un minus 1. So over here on the left hand side, un minus u0 is actually un minus 1. They were lazy, they never substitute in. Then at the end of the day, how come this minus 2 turned into minus 1? It's because the minus 1 bring over become plus 1. So minus 2 plus 1, you get a negative 1. Okay, good. But then that is the left hand side settled already. But how did they simplify the right hand side? How did they simplify the right hand side into all this formula here? First thing you must remember, there are two types of series in the syllables that you need to remember. Arithmetic series and geometric series. I'll just shorten as AS and GS. There's a formula for it. For arithmetic series, it's Sn equals n over 2 multiplied by a plus l. So what is n? N is referring to number of terms. And a is first term, l is the last term. Okay, then for geometric series, it is Sn equals to first term a multiplied by 1 minus the common ratio r power n, or divided by 1 minus the common ratio. But of course you can times negative 1 to the top and bottom. Okay, then this means you have to distribute the negative, and you eventually end up with swapping the order of the r power n and the 1. So this actually changes into r power n minus 1 and r minus 1. Equivalent, it's equivalent. Where a is referring to the first term, just like the arithmetic series. R is referring to the common ratio. Common means it's the same ratio. Then n is referring to number of terms. And yeah, that's it. So take note that now how do you identify what is arithmetic series and geometric series? 2 power r sum from 1 to n, that is a geometric series already. What does it mean if you take the sum 2 power r equal to 1 to n? 2 power 1 plus 2 power 2 plus 2 power 3, 2 power 4, until 2 power n minus 1 plus 2 power n. What's the pattern? It's a summation, but you have times 2, times 2, times 2, times 2. Everything is times, that's why it is a common ratio. Fixed number 2. So what's the first term? Over here, 2. What's the common ratio? Over there, 2. So that means that a is equals to 2, r is equals to the common ratio of 2, and then what is the number of terms n? In this case, n is just n, because you see r from 1 to n. In general, the number of terms is n equal number of terms would be upper limit minus lower limit plus 1. So like upper is n, lower is 1, n minus 1 plus 1. That gives you n. If you have, let's say, a random example, summation of, I don't know, a happy face, subscript I, and I goes from 5 to 7. How many terms are there? Happy face subscript number 5 plus happy face subscript number 6 plus happy face subscript number 7. Replace the I with a 5, a 6, a 7. Then you add them together, plus sign in between. Now, how many terms are there? 3 terms, obviously. But of course, how do you get a general formula for the number of terms 3? It's number of terms, let's just denote it as n. It will be upper limit 7 minus away lower limit 5, then plus 1. That gives you your number of terms 3. Upper minus lower plus 1. Okay, so now that you have identified the A, the R, the N, then you just need to sub into the formula. A, R, N, and R again. That's how you get the first formula here. Geometric series formula. Then how about if I just want to look at the arithmetic series now. Sorry, I should mention what series is this first? It's a geometric series. How do I know that? Because I just sub in manually in my head. I realize that if I go to 1, 1 minus 1 is 0, plus if I go to 2, 2 minus 1 is 1, then plus 1. If I goes to 3, 3 minus 1 is R minus 1, R replaced with 3, 3 minus 1 is 2, then I plus 2, then I continue so on and so forth until I reach n minus 1, then I get n minus 2. Sorry, that was confusing. Let me try again. If I reach r equals to n minus 1, substitute in r with n minus 1. Here. You get n minus 2. Last one, you sub in with r equals to n. You get n minus 1. So what do you notice? Common difference, d equal plus 1. Common difference, d equal plus 1. Plus 1, plus 1, plus 1. Then what's my first term? So because there's a common difference now, that means that this is a arithmetic series. What's my first term? 0. What's my common difference? 1. What's the total number of terms? N, because you have upper minus lower plus 1. Oh, n minus 1 plus 1, that's n. Then now that you know you have A, you have D, you have N, you got the formula over here, just use the formula, sub in. Oh, right, how do you get the last term, L? You just have to substitute in the R with the last index number. In this case, it's the upper limit, N. So in this case, it will be last term L is actually just equal to substitute R with the last index N minus 1. Okay, that's how you get your last term. In general, there is a formula for the last term. The last term is always also known as the nth term. Assuming you're summing from I equal to 1 to n of some expression in terms of I, some fxi, for example. That would be, what would it be? It will usually just be a plus n minus 1 times d if this was a arithmetic series. Substitute in the r with an n. Oh, that's how you get your L. So that means that there is an alternate formula for the arithmetic series. Instead of Sn equal to n over 2 times a plus L, you can replace the L directly with a plus bracket n minus 1 times d. But what's a plus a? It's 2a. So n over 2 times 2a plus n minus 1 times d. That's an alternate formula. You can also use this. Yeah. Then after that, you get these two expressions. You just simplify. Simplify up to this step. 2 minus 1 here is just a 1. 2 divided by 1 is just a 2. So 2 you can multiply in. Oh, this 1 can just disappear. I can just ignore it, the denominator 1. So 2 multiply into the bracket. What do you get? 2 times 2 power n. 2 is just 2 power 1. So same base, 2 different power, 1 and n. Multiply. What happens to your power? You add the power. So 1 plus n. N plus 1. 2 times negative 1, negative 2. Okay, good. Then next one, 0 plus n minus 1. Oops. 0 plus n minus 1, n minus 1. Then you just have n over 2 times n minus 1. Yeah, then just now I already explained, minus 1 bring over, become plus 1, minus 2 plus 1, get a negative 1 over there. and then we're done.